Hey guys, welcome back, and today we'll be continuing area, but we'll be doing more complex figures. So let's say we had this here. Right? And here is 2 centimeters. Here is 7 centimeters. This is 5 centimeters, and this is also 5 centimeters. So the first thing you'd want to do is look to see the different shapes that make up the object. So here, this is a square, because remember, squares, all sides are equal. So if this here is 5, that means this entire region here. So what we could do is split it like that and say this is 5 centimeters, 5 centimeters, 5, 5. Right? And then we have a rectangle here. This is 7 centimeters. This is 2. That means this is 2 here as well, and this is also 7. So what we do first is find the area of the square, and that is length squared. So it is 5 squared, which is 25 centimeters squared. Then we find the area of the rectangle, which is length times width. So that's 7 times 2, which is 14 centimeters squared. Now remember, it is a compound object, so that means we're going to add both the area of the square and the area of the rectangle to get the total area. So it's 25 plus 14, which gives us 39. Okay, let's say we have this shape right here. And this here is a room. Let's say we want to find the area of the shaded portion, which is this area around here. What we need to do first is look at the shapes. So the small shape, which is for the room, is a square. So we need to find the area of the room, which is a square, and that is 2.5 times 2.5, which gives us 6.25 centimeters squared, right? Then what we need to do is look to see what shape the bigger object is, which is the rectangle. And we know that the area for the rectangle is length times width. So that's saying 12.5 times 5.6. And that gives us 70 centimeters squared. Now, because we want to find the area of the shaded portion, we're going to say the area of the larger part, which is the rectangle, minus the area of the smaller portion, which is the square. So it is 70 minus 6.25, and that gives us 63.8 centimeters squared. Let's say we have this here. So if you look closely, you would realize that this here is a rectangle, and we have a triangle here on the inside. So let's say we wanted to find the shaded region, which is here. The first thing we need to do is separate the shapes that we have. So we have a rectangle, which is 18 cm, 10 cm. So if this is 18, that means this is also 18. If this is 10, that means this is also 10. So the area for the rectangle is equal to 10 times 18, which gives us 180 centimeters squared. Now we have the triangle. The base of the triangle was the same base for the rectangle, so that means here is 18 centimeters. And we're given the height as 6 centimeters. So the area of the triangle, half times 18 times 6. So this into that, 9 times 6 is 54 centimeters squared. And all we need to do now is just subtract the area of the rectangle and the area of the triangle. So it's area rectangle minus area triangle, which is 180 minus 54. And that gives 126 centimeters squared. Okay, so let's say we're given this here, and we're told to find the area of the shaded part, which are the parts in green. So first we'd identify that there is a square. So there's a square. And we'd identify that there is a circle. So we know that the area of a square is length squared. And we know that the area for a circle is pi r squared. Right? So based on this, we're given the diameter. So that means the length of each side of the square is 28. So area of a square, which is L squared, is equal to 28 times 28. And that gives 784 centimeters squared. Now the area of the circle is pi r squared, and let's say we're using pi as 22 over 7. The diameter, which was 28, we could find the radius by dividing that by 2, and that would give us 14. So it is times 14 squared. And that's equal to 616 centimeters squared. Now, how would we find the area of the shaded part is by saying the area of the square, because the square is larger than the circle. So it is area of the square minus area of the circle, which gives 168 centimeters squared. So let's say we wanted to find the area of the shaded region of this complex shape here. First, we need to realize that this here, in its entirety, is a trapezium, right? We could split this into a semicircle here. This is also another semicircle here, and this is a rectangle. So this is a semicircle here, and the formula that we would use to find the area of the semicircle is the regular formula for a circle, but we divide it by 2 because semi means half of a circle, right? So what we're going to do is we're going to use pi as 22 over 7, and r, which is the radius, is half of the diameter, and the diameter is 14, so we're going to say 7 squared, and whatever we get, we're going to divide that by 2. So 7 and the 7 cancels. 22 times 7 gives you 154, and if you divide that by 2, you're going to get 77 meters squared, right? So because we have 2 semicircles, we could have kept the 154. Now we want to find the area of the rectangular portion of the track, right? And we were given this here. This was 56. This is 14. So it's length times width, which gives 56 times 14, gives you 784 meters squared. So the total area for the track is 77 for the first semicircle, plus 784 for the rectangle, and 77 again for the second semicircle, and that would give you 938 meters squared for the track itself. Now if you looked closely, you would realize that the outer part was a trapezium. So the formula we use for the area of the trapezium is half a plus b h, which is half a, which is 80, plus b, which is 100, times h, which is 30. And all of that would give you 2700 meters squared. So now we're going to say the area of the outer part, let's call that A2, minus the area of the track, which we're going to call A1. That would give you 2700 minus 938. That would give you 1762 meters squared. So the easier way to do this is just split them up into smaller portions and find the area of the parts you know, and then combine and subtract. So thank you guys for watching, and see you guys next time.